So the solution concentration is a measure or ratio of the amount of solute compared to the amount of solution. So that ratio is going to be the only ratio that we see in this class for all of the concentration units that we are going to encounter. So we're going to be looking at the amount of solute compared to the amount of solution. All of the concentration units are going to have that ratio. So the one thing to keep in mind, though, right, is we're looking at the relationship between solute and solution. What's the solution made up of again? The solution is the combination of the solute and the solvent. So it may not seem like a big deal, but it actually is when you start, adding these things together. So don't lose track of your definitions of solution versus solute and solvent. All right, so we're going to take a look at 4 concentration units. 3 of them are percentage units, so we've seen percentages before. And then the 4th one is going to be the concentration unit that we see a lot of in chemistry, which is molarity. All right, so the first one is called mass percent, or sometimes older textbooks use weight percent. And oftentimes this is abbreviated as M over M percent or W over W percent. Right? Those are common abbreviations for this concentration unit. The mass percent is simply the mass of the solute divided by the mass of the solution times 100. That's a percentage. Right? Percentages we saw, back in chapter 1 or 2, it was always the part over the whole times 100. Here, the whole thing is the solution, solute and solvent. The part now is the solute that we're looking at. And that ratio is going to be the same for all of the units. Mass percent is something that you are probably way more familiar with than you actually think. So if you're thirsty, you go to the grocery store and you buy some milk, if that's what you use to quench your thirst. So you get some milk, right? And you buy whatever the 1%, let's say you buy 2%, the good stuff. So 2% milk, right? That is a percent concentration by mass. Because your milk is actually a combination of several things. It's not just water. It's mostly water, but there's other important stuff in it that you need for your body to function effectively. So what this means is that you actually have 2 grams of the solute that the 2% is representing, which is the milk fat, for every 100 grams of the milk. And a percentage times 100. So 1% milk would have 1 gram of fat for every 100 gram of milk. And then your skim or whatever, has a very, very small percentage, way less than 1%. And it just tastes like water at that point, right? Might as well just drink water if you want to do that. Or just, fast or something, I don't know. All right, so that's your mass percent. Volume percent is the same idea, except now we're looking at the volume relationship. So the amount now, the unit for the amount is the only thing that's changing. So we're looking at the volume of the solute divided by the volume of the solution times 100. Volume percent, just like with the mass percent and the weight percent, this is often abbreviated V over V. volume percent. This is also a unit of concentration that you're probably more familiar with than others, right? And some of us may be more familiar with this than other people. So again, you go back to the grocery store and you're thirsty and you reach for the milk. They're all out of milk, right? Somebody had the same idea like you did. So you go to the next best aisle. You go to the alcohol aisle. And let's say the only thing available is some beer or something, and you grab the one, whatever, and it says 6%, let's just say. 6%, and it says ABV. Does that look familiar? Some of you? You don't have to respond. I apologize. Okay, so ABV stands for alcohol by volume. ABV. That's a concentration unit expressed in volume percent. So what that actually means, right, is that you have 6 milliliters of the solute in your beer or whatever it is, which is the alcohol, for every 100 mils. Let's just assume this was beer, of the beer, times 100. Right, the alcohol, the ethanol is what the active ingredient is. Right, that's what gives it its properties, good or bad. That's an indication of how much you have dissolved in that whatever that drink is. Right, so 6%, 6 mils for every 100 mils. And if you wanted something a little more poisonous, you go and get some tequila or whatever, and it says 40%. Right, that means you have 40 mils of alcohol for every 100 mils of that drink.
So why do you use mils?
You could use any unit, right? I could have used 6 gallons of alcohol for every 100 gallons of beer.
Then I
it's
would
the
understand.
percentage. Yeah. Six %. Okay, and then the last concentration unit is just a combination of the first two, and it's mass volume percent, which we often abbreviate as M over V percent. Again here, the ratio is going to be the same. It's solute for solution, but now it's going to be the mass of the solute divided by the volume of the solution times 100. Right, so the ratio is the same thing in all three cases, solute to solution. What makes them different is the units that we're using. Is it mass over mass? Is it volume over volume? Or in this case, is it the mass over the volume? All right, so let's take our analogy to its logical conclusion. Okay, so you go to the grocery store, you're thirsty, you want to get some milk, there's no milk. So you go to the alcohol aisle, all out of alcohol, because you drank it all right? And then you ended up at the hospital, right? You're in the ER or whatever, and they have to stick you with an IV because you've been throwing up or whatever. You've lost a lot of electrolytes. What does the IV have in it? So it's a saline solution. What is saline? It's just a salt water solution. Does anybody know what that concentration is?
0.9%.
Yes, it is 0.9% sodium chloride. Right, that's your saline solution. That goes directly into your bloodstream, right? So it has to have this roughly the same concentration as everything else in your blood. If it's different, you can suffer some serious consequences, right? If it's too high, you can essentially dehydrate from the inside out. That is not pleasant. You end up losing water from all places. That's why you don't drink the seawater if you're on a deserted island, right? You just end up dying. So 0.9% sodium chloride is a mass volume percentage. So what that means is that you have 0.9 grams of the solute NaCl for every 100 grams of the saline solution times 100. Right, next time you have an IV, take a look at the thing before they stick it in you. Right, so you should confirm that it's 0.9%, and they're not trying to kill you or something.
You're just using grams because you can?
We're using I'm sorry, whoops.
Yeah.
For 100 mils. I apologize. So mass over volume, you should have a unit of mass divided by a unit of volume. Right, so grams over milliliters would make sense for the 0.9% NaCl or saline solution. So those three concentration units are all percentages, right? So they describe the mass, the solute over the solution, whether it's mass over mass or volume over volume or mass over volume. The last one, I'll just introduce this before we finish, is molarity, and it is also going to represent the relationship between those two things, right? What the molarity is, though, is now moles of the solute divided by the liters of the solution. It's the same ratio, solute over solution, that we've seen in all the other three cases. It's just the units now that make them different. Chemists tend to use this because there's moles in it, and we like moles. All right, but you go into the health field, you're going to see more percentages rather than the molarity.
That's not times 100 though.
No, this is not a percentage. Right, the others are percentages, so you multiply them by 100. This is just the ratio of moles of solute per liters of solution.